All right, so we're going to be looking at the quadratic formula, and before we start talking about the quadratic formula itself, first we're going to talk about the standard form of a quadratic. So quadratics can come in a number of forms, but for standard form, we always want it to look like this: ax squared plus bx plus c, and this usually equals 0 or it equals y. Depends on whether it's a quadratic for graphing or if we're solving a quadratic. We'll talk about that later. Okay, so we always want it in this form, and then these coefficients are the a, b, and the c in the quadratic formula itself. And I recommend just writing it down. I always memorize things by writing it down repetitively. So every time I use a quadratic formula, I write it down first. So negative b plus or minus the square root b squared minus 4ac. Extend that square root a little. All divided by 2a. All right, so the a, the c, and the b in the quadratic formula are always from our quadratic in this form. So that's important to remember. Okay, so what is the quadratic formula actually telling us? Well, there's two things it tells us. One, it can tell us what the roots or the x-intercepts of the quadratic are. So if you remember, think of a graph of a quadratic. If we just do a real quick sketch, and it might look something like this. These are the roots where it crosses the x-axis. Okay, so it can tell us that. It can also tell us the solutions of a quadratic, and those are very similar but slightly different things. So the solutions are telling us what x is in some equation. So if we take a peek at the next two examples we're going to do, in this one we want to find the roots because it's y equals 3x squared plus 10x plus 8. And this one we're solving, which means we're trying to find the x value that makes our equation true. So we're solving this, and it equals 0. Sometimes you may see people say, find the roots of this is the same as solving, but there's a slight distinction there. Either way, we're going to use a quadratic formula. So let's do this first example. So to start off, let's identify a, b, and c, and let's recognize that this is in the correct form, ax squared plus bx plus c, right? We'll do an example later where it's not in the correct form. We're going to have to fix it just to go over that. So let's plug it in. So negative b, so negative 10 plus minus the square root of b squared minus 4 times a is 3 times c is 8. All right. All divided by 2 times a. And we're definitely going to want a calculator for this. Sometimes it'll work out nice. This one will actually work out pretty nicely, but calculators are handy. And I like to do it in little pieces. So let's see. So I'm going to start by doing the inside of the square root. So we're doing BEDMAS here. And one thing to note about BEDMAS is everything under a square root is in a giant bracket. It's always the first thing we're going to tackle. So 10 squared minus 4 times 3 times 8. And according to my calculator, that is 4. So we're going to have negative 10 plus or minus the square root of 4. All over 2 times 3, well, that's 6. Top and bottoms of fractions are also in giant brackets, so you can't do like 10 over 6 and write that down and do plus or minus root 4. You got to do the whole top first. Okay, so one important thing to note is that we got this plus minus, and this is going to give us 2 results. And that kind of makes sense if we think about our graph from up here. We got 2 roots, so that makes sense. We get 2 results. Let's see, so I'm going to split this up into 2 little pieces. So let's do x equals negative 10 plus, and the square root of 4 is 2 over 6. And we'll do a separate one. And this is our second answer. X is negative 10 minus 2 over 6. All right, so we want to simplify these down. And let's see, so here we got negative 10 plus 2, so that's negative 8 over 6. And you may be tempted to write a decimal, but we're just going to simplify the fractions. So that's negative 4 over 3. And for this one, we get negative 12 over 6, and that's exactly negative 2. And I'm running out of space here. Hopefully you got a bit more, but we're going to write a little conclusion. So when we're finding the roots, we're finding points. So these points are an x value where the y is 0. So I'm just going to write that over here because I'm at a spell. Maybe we'll squeeze it down here. No, we're going to do it over here. So roots are negative 4 over 3, 0. And negative 2, 0. All right, so let's take a look at the second one. So for the second one, we want to solve this equation. So for solving the equation, we're going to use quadratic formula here. So let's start writing that down. So x is negative b, so negative of negative 6, that's positive 6, plus or minus the square root of negative 6 squared minus 4 times 2.5 times 3.6. Okay, all divided by 2 times 2.5. So I recommend every time you plug a number in, you put it in brackets, because here, where we have negative b squared, it's a negative 6 now. Still kind of looks like a b, my bad. It's important to remember that the negative is being squared. And you have to be really careful on your calculators. Some calculators, if you type in negative 6 squared, it's going to tell you that that is negative 36. And that's not true. Negative 6 times negative 6 is positive 36. The reason your calculator is doing that is because it is squaring the 6, but not the negative. In order to get it to square the negative, you need to put the whole thing in brackets. And this is why it's really important to understand and know your own calculator, and why I really recommend you own a good calculator and not borrow your friends all the time. Because if you plug this all in at once, who knows what's going to happen. So I'm going to be very careful. I have to put mine in brackets. Negative 6 in brackets squared minus 4 times 2.5 times 3.6 equals 0. Interesting. So let's see. So we get x is 6 plus or minus the square root of 0 over 5. So I guess that means there's not really a splitting up to happen, right? It's plus 0 minus 0. It's the same thing. So we get x is just 6 over 5. All right, so because we got plus minus 0, it looks like we only got one answer. And the reason we got one answer is because we had a 0 in the square root. And that's what we're going to talk about next, is how the number in the square root can actually tell us something about how many solutions there are to a quadratic, or how many roots there are. So if we were to graph this shape, it would look something like this. If it only has one root, it would come down and just kind of touch the x-axis and then come back up. Okay? So sometimes we call that a double root. All right, so the discriminant is the part under the square root. The discriminant is b squared minus 4ac. And just by looking at the discriminant, we can tell a few things about a quadratic. So if the discriminant is greater than 0, so if it's a positive number, then there's going to be 2 solutions or 2 roots. If the discriminant is equal to 0, that means there's only going to be 1 solution. That's what we saw in this example over here. Or a double root, which is where it kind of bounces off the x-axis. I have air quotes around that. You can't see that, but there's air quotes. It bounces. It doesn't really bounce. Okay. If If the discriminant is less than 0, as in if the discriminant's negative, well, if we think about that for a second, if we have a negative under the square root, you can't do that. You can't square root a negative. It's illegal, right? It's like against the rules of math, kind of. Okay, then we say there's no real solutions. Real, what does that mean? Or roots. So the real has to do with the fact that we can't square root negative numbers. If when you go to university, if you're doing math stuff, you might learn about imaginary or complex numbers, in which case you can square root negative numbers, or you kind of can, and you do some trickery around that. Okay, but those are not real numbers. Real numbers can't square root negatives. So we say there's no real solutions or roots. All right, so let's see how we can use the discriminant. So use the discriminant to predict the number of solutions. So we don't even need to know what the solutions are. We just need to predict how many there are. So the first thing I notice about this is it is not in standard form. So we're going to have to fix that. So in standard form, it always equals 0 or y. So let's rearrange first. So we could move the 11 to the other side by subtracting it on the other side, right? So we get 0 equals x squared minus 6x minus 11. Now it's in standard form. Now we can use the quadratic formula. Well, we could use the quadratic formula to solve it, but we don't need to. We just need to use the discriminant. So let's just use the discriminant. So b squared minus 4ac is equal to negative 6 minus 4 times a. In this case, it's going to be 1 times c is 11. So, oh, I forgot the squared. Okay, so negative 6 squared. You can use your calculator for this if you would like. 36 minus 44. Oh no, that's going to be negative for sure. I think that's negative 8, but it's been a long summer without math, so we're using a calculator today. Negative 8. Negative 8. So that's a negative. So negative discriminant, once again, that means that there are no real solutions. So we'll write that as a solution. So therefore, there are no real solutions. Oof, rough writing. All right. All right, that is all for today. Thank you.